In this video, we'll be looking at hyperbolic trigonometric functions, and one in particular, the hyperbolic sine function, which is often written like this, and some people pronounce it Sinch, or sometimes shine, but probably Sinch is more common. So, the hyperbolic trigonometric functions are just like the regular ones, except you have to put, it's hyperbolic, so it's based off a hyperbola. So let's put the analogy. You know those regular trigonometric functions? You have the unit circle, which is given by x squared plus y squared equals 1. And if you have an angle of theta here, then sine of theta, remember sine of theta is given by opposite over hypotenuse. So that's just going to be the height right here over the radius, which is 1. So it's just going to be given by the height right there. So that's how we define those. Now, hyperbolic trigonometric functions are surprise based on a hyperbola. So if we draw a unit hyperbola, so it's just going to look like this. I'll try to draw it as nice as possible. And this is given by x squared minus y squared equals 1. And I'll draw in the asymptotes which pass through the origin. Okay, this came out bad. Okay, so if we draw the asymptotes, then how the trigonometric functions are defined for hyperbolic. So I'm going to do the one for sine. So for example, let's pick a point on the hyperbola. So this one right here. Then what we do is I'm going to draw a line from the origin to that point. And then all this area inside here, we're going to call a over 2. Then the hyperbolic sine is defined as this height. So this height you see right here, this height is hyperbolic sine of a. And that's how it's defined. And it gets more complicated than that, but we won't go into all this hyperbola stuff right now. So that's how they're defined. And the hyperbolic sine, it has this exact definition. So hyperbolic sine of x is given by e to the x minus e to the negative x over 2. And that's how it's defined. And hyperbolic cosine is given by e to the x plus e to the negative x over 2. So in this video, we'll be going over a bunch of identities and stuff that arise from the hyperbolic functions and how they're defined. So first one we can look at is hyperbolic sine is just like regular sine in that when you put hyperbolic sine of negative x is just equal to negative hyperbolic sine of x. So that means it's an odd function, and just like the same way, hyperbolic cosine, or cosh, people write it as C-O-S-H, x is a even function. And other things we can say about it, the identity that you have in your regular trig, you know, that sine squared x plus cosine squared x equals 1, that holds here, but in a different form. So it's going to be cosh squared x minus sinh squared x equals 1. So that's how it's going to be. And that's all because it's coming from the hyperbola instead of a unit circle. And other things we can say about it is that if we add sinh x and cosh x, then we get e to the x. And that's easy to see because if you take the definition, if you just take e to the x minus e to the negative x over 2, and you add e to the x plus e to the negative x over 2, these will cancel and just 2e to the x over 2, which is just e to the x. So that's interesting to know. And if we go into some of the calculus of these things, then we're going to see that the derivative of sinh of x is given by cosh of x, but unlike in regular trigonometric functions, the derivative of cosh of x is not negative sinh of x, but instead just sinh of x. So if you want to prove this to yourself, go ahead and use the e to the x definitions of these. And other things we can look at is, for example, the Taylor expansion of sinh of x. Remember the sines? Sines Taylor expansion looks something like it was just 1, and then you had minus x cubed over 3 factorial, and then you had plus x to the 5th over 5 factorial, and this is not a 1, this is an x, so and so on. And all these signs alternated. Well, they alternated because if they didn't alternate, then they would be the expansion of sinh x. So that's interesting to know as well. And other things that we can note about them is there's one definition that says sinh of x equals negative I sine I of x, which comes from imaginary things, and we could prove that eventually, but it might be an advanced proof. So, and possibly the last thing we'll talk about in here is an integral that involves this. So if we have integral of 1 over radical x squared plus a squared, where a is just some constant, dx, then that equals sinh, inverse sinh of x over a plus the constant. So the interesting thing is we couldn't evaluate this integral without sinh. So that's the hyperbolic sine. And I didn't talk about the other ones, but you have your hyperbolic sine of x, you have your cosh of x, and if you divide them, you get tanh of x, and then there's also cosecant, secant, cotangent, hyperbolic, and they're actually really interesting things, and it's kind of sad they don't teach them in school, but I mean, that's what we're doing this here for. So, till next time.